I've been wearing my mask last few weeks. Uh, uh, it looked weird, right?
Tejaswini, do you want to get
Hi.
started? Yeah, I was just about. Yes, I think we have quite a few folks. We could get started. Yeah. Do
Okay.
you want to start with MaxEc discussion?
Yeah, I think let me start. I don't see other folks who had, I only see Dipankar. Okay. I also see, I don't know it's a handle or it's a name. Kisara? What's the name?
The
Yeah,
Shrikant.
this is Srikant.
Shri- Shrikant, okay. Shrikant, which company you are from?
This is Nokia.
Okay, okay, good. So at least then I have a couple of folks. All right, okay, I'll get started. So we had that discussion in the last meeting where we were talking about the IPsec engine instances which are present in the switch, and I think Dipankar clarified that the way it was designed, that list is supposed to have only two instances. Let me share my screen so that we know what we're talking about. So this is what Dipankar clarified. Excuse me. So there are only two instances of engine in the switch list. Let me go to the code. Sorry, my machine decided to upgrade, so it's very slow right now. I don't know
So
why.
Jay, while you were updating the screen, could you, the terminology we used was just SAI MAXSEC and SAI IPsec in Psi, right? And when we say engine, we normally refer to potentially,
The
but
hardware, right?
sometimes hardware. So that is part of the confusion because I kind of described in the document, in the Psi, I used the name that what SAI MAXSEC is a security engine, but essentially it did not decompose into multiple parallel instances, did not try to differentiate between multiple parallel instances or serial or one engine or something, right? It was just a function.
Right. Yeah. So, okay. Yeah, Dipankar, you're right. So you see the psi maxsec object. Okay, so that's correct. So we refer to in the psi, we typically say objects, right? And these objects are representation of the hardware instances or the engines, right? So this object actually, although it's a list, it's not infinite list. It's a list of only two objects. One object is in the ingress direction, one object is in the egress direction, and then object references. Assumption in this spec is that object references to a hardware engine or a hardware instance, and does not specify are there one instance of IPsec MaxSec or there are more than one, right? So that's that's kind of where it was left. Now further on, for MaxSec, it's really not that big of an issue. This psi MaxSec object, let's say if it references to multiple hardware instances, the configurations are such that the single object attribute in the psi MaxSec.h suffices. It's applicable commonly to all the hardware instances. Now, that is not true for IPsec. Okay, IPsec has a concept of flow. There may be a flow specific configuration for IPsec and will differ from hardware instance or within a hardware instance, right? So Dipankar and I had a discussion that what shall we do? There is a hard assumption in the MaxSec and SciSpec about this, then what do we do? So I think we came to a conclusion, and this conclusion is what Dipankar has added as his comments. Sorry, my computer is painfully slow. Let's see. This is what we have. You have added, Dipankar, right? I think probably Dipankar, you're on mute.
Yes, this is what I added. Yes.
Okay, so essentially what we are thinking, and this is what I wanted to bring to the community, what we are saying that when the post is run on a SciMaxec object, internally, it may run on one or more hardware objects. So in the documentation, if you see, there is a clear mention of 1:n, right? That there might be n Sci object instances as well, where we are saying that current spec is creating only single SciMaxec object. Internally, it may be referring to multiple hardware objects, but Sci will run on a one, post will run on a single Sci object, which in turn SDK or any implementation may run on multiple hardware objects, but the status will be returned on a single SciMaxec object granularity as defined currently. If there is a failure, then NOS has to query the port status to get what port or ports the post has failed. So that's kind of a summary of this comment, right? So we don't want to change anything in the current spec. The only thing changes is the documentation. The let me go on the code, but that's first I want to just clarify, wait, if there are any questions on that before I go in the code and say. So I hope that is clear. If that's clear, then I can go in the more details.
So Jay, one thing I wasn't sure of, are you sure you want to leave a post attribute for the SciMaxec and SciIPsec objects? I meant enable post attribute.
So right now, the granularity which has been defined, one is at a switch level. Again, I was coming to that, but one is at a switch level. Second is at a Sci object level, right? And let me see, is there at a port level as well? There's nothing at a port level. It's only at a MaxSec object level. Let me make sure. Yeah.
So what that will do is that you're enabling post individually for receive and transmit side of the object.
Probably, yeah. Because you're going to create one RX object, one TX object, and then you can enable it at a RX TX individually, or you can just enable at a switch level. That's the only mechanism we are providing.
So I don't see a benefit of separating receive and transmit for post, because but maybe there is some I am not aware of.
You know, there are other vendors as well. So if we have agreement, then we can completely take out, you know, the object level trigger. But that's something which we need to have a consensus. And let me, I'm bringing Shantanu as well. I don't think he has joined.
Hey, I'm here, Jay.
Oh, you're here? Okay, good. So yeah, so you know, I don't have from a spec point of view, Dipankar, I don't see an issue. It's what's needed by a given implementation, right? Does it solve the purpose of all the implementation? If it does, then I'm okay with it. But I'm looking for a feedback. So question, Shantanu and Shrikant, the suggestion is that shall we take the enablement of the post at a SciMaxec object granularity? Because here, this object will be created, one for the RX direction, one for the TX direction. And essentially what this will mean that you enable it, one for the RX, one for the TX.
So your question is whether we even need it and whether we just do the switch level.
Correct.
I mean, the practical use case is where we use it at the switch level, right? So I mean, from an application usage or a lab certification point of view, the switch level has everything we need, at least the one use case I'm aware of. So I think from that point of view, it's okay. If someone else has a use case where they need specific object level manipulation, I think they can speak for
No,
themselves.
only for diagnostic reasons, right? For a
Okay.
FIPS, from FIPS perspective, this level is good. Everything else is for diagnostic purposes.
So I'd like to reiterate again, though, that the granularity you're getting is the post-failed on the transmit side or post-failed on the receive side. So from the FIPS perspective, you have to disable FIPS if it fails on a port granularity, but not a receive or transmit granularity.
Right. When the expectation if it fails, and
Yeah.
you would not use.
So normally diagnostics features, if there's any further diagnostics to be done, those are not really exposed to PSI, right? That's vendor specific and implementation specific. So I'm not sure if it helps.
Dipankar, that's not true. There are a lot of attributes which are mainly for debuggability or extracting debug stats, etc. So that statement is not true. We do provide knobs, which are present for operational reasons.
Sure, I understand. When I was doing that, I was saying from the perspective of when we are doing the SciMaxSec and SciIPSec APIs, I was told that doing diagnostics attribute will be very hard because of different implementations. Stay out of it, kind of. So that was part of the reason these security engines are not exposed.
Yeah, so I mean, I don't see an issue that what we can do, we can capture comments that these attributes are presented mainly from diagnostic purposes. Okay, these MACsec post enable and IPsec enable for FIPS compliance, and that I'll put in comment as well here. I can add it, and as well as in the documentation. That's option one. Option two is a lot more simpler. I completely delete 346. I mean, completely delete then all my callbacks, everything. The changes become a lot more simpler. So if you ask my preference, then I would say delete everything. Keep the diagnostic.
Let me pose the question to Santanu for making sure. So we are only talking not of the status. At this point, we're only talking of the enable post. So Santanu, post can be enabled on a transmit and receive individually in your implementation, and you would like to enable that.
Correct. Because, it's encryption and decryption, right? So the vectors are different. So, when in the FIPS SDK layer, you have to run two separate. It's like two separate tests, right?
Okay.
So yeah, I mean, there is a value in getting the information which one failed when it fails, and it's for diagnostic.
But that is from the status, right? Do you want to enable?
Not for FIPS, right? Not for FIPS. FIPS will disable that port, whether encryption fails or decryption fails, right?
Just to be clear, my question simply is there an advantage in individually triggering the FIPS test for transmit and receive? Not for the status. My question is about triggering.
Triggering, there may be. Is this implementation dependent? Yes, there may be.
Okay.
There may be some implementation where those things, triggering those things separately is definitely beneficial.
Okay. Then if you want to keep the diagnostics features, by all means, I mean, I cannot argue against that.
So do we plan to keep it? Do we have a consensus, or we are still debating?
Keeping it doesn't get in the way of anything. So I mean, it's perfectly fine to keep it. It adds value there.
Okay. I'll change the MACsec. Object level post enable is mainly for diagnostics purposes. Add comments in documentation and header attribute clarifying this. Okay, I will
So just to be clear, so you need to enable it for every object as well as at switch level in order to run post. Is that correct?
Nope. So I think the way I understand diagnostics will be, let's say the system started, okay, and at a switch level, we enable the post passed, system is up and running. Now, for whatever reason, let's say that's one scenario, one use case, right? In that case, now somebody wants to run diagnostics at a MaxSec object level, then these objects, everything is
Wait. So when the switch is created with enable post maxsec, it will not run the post, right?
it will run the post. Why it should not run the
The
post?
maxsec object hasn't yet been created, right? So then the maxsec object is created, then it will run the post because it has to check if the enable post is there or not, right?
No. So this attribute has no meaning for the FIPS compliance, right? This attribute has no meaning.
Okay.
This attribute, Shantanu, and this is very, very classic, the way we create overlapping attributes. Let's say some attributes are at a tunnel level, some attributes are at a switch level. Then we say that then which one takes precedence, right? In this case, switch level attribute will take precedence, essentially. It's not two conditions which need to be ANDed or ORed, right? There are two exclusive conditions, one supersedes other.
Oh, this will remain a create and set.
Yeah, this will remain created. Otherwise, how do you do the diagnostics?
I didn't understand the proposal here. So the switch level is going to be create only, and this one is going to be create and set, or
yes, that is correct, right? So, and I think that what we agreed last time, and I think I did added that comment. Change the flags to create only. You see my screen?
Yes, and that applies only to the success switch object. Okay, got it.
Right? Yeah. The MaxSec level will just remain create and set because you want to change the runtime.
Okay.
Right? Okay. I have 8:30 meetings, so I was hoping that I can conclude this. So okay. So that's the changes I'm going to do. Correspondingly, documentation will change, and I hope that's agrees. There's one more comment which I saw, which I think. Sorry, finish your review. I want to do that as well. There was one more comment from Dipankar, which you were following, right? So this one was saying that boot time, and Shrikant, maybe you can help me here because this person is not here, or I don't know if this there.
He's on a break.
Okay. Yeah. So I think here the suggestion here was that during the anytime the post runs without any intervention, without any enabling, right? So this one we are kind of not suggesting.
The only issue with that would be that if somebody is not interested in running FIPS compliant,
correct.
Then it means that if for any reason it fails, MaxSec is not available to you.
Right. Yeah. This makes behavior. This makes okay.
Oh, so it's expected that the SDK or the hardware is going to disable the MaxSec automatically. It is not in NOS's hands when the post fails.
Right. If the post is run and it fails, then that is the expectation.
So that is not good, though. What I suggested is not really a good solution.
Okay.
But I think Wolf's concern could be addressed. I think he spoke to us before he went on the breaks. I think we should be okay.
So you always run FIPS, and if it fails, they always run post, and if it fails, that you disable MACsec.
Right, from an application, right, we would, based on the configuration of the switch, we would request post or not. If FIPS mode is enabled, we would request post. Otherwise, we would initialize the SI. That should take care
Got it.
So basically, if until post passes, if it is FIPS enabled platform, until post passes, the MACsec is disabled, right?
That's correct.
So yeah. So if you have not triggered it, if you have not passed it, in either case, it is disabled. So until it passes, that's what should be the hardware behavior. If it is FIPS enabled. Now the point is how are we saying a platform is FIPS enabled or not? Because it's usually done by hardware, right? Either somehow
it's not so much FIPS enabled. I mean, requesting
FIPS certified requirement. Go ahead. Yeah, FIPS certified or not.
But requesting post is an indication that you want to run in a FIPS compliant mode, right? If you don't request post, then you're not running in a FIPS compliant mode is not important. So the act of requesting post will say whether you want it. If you don't request post, then allow the MACsec engines to be enabled.
So basically what you're saying, if I understand right, is that when you instantiate the switch, you should enable the Boolean flag for running post only if you want to run certified mode, otherwise don't. If you want to do it for potentially, if you want to still run post without enabling FIPS later on for diagnostics, that should have no influence on that automatic MACsec enabling or disabling.
Right. If somebody wants to run post later after everything's been running, then that an implementation could decide that maybe they won't support it if you didn't do it at the beginning. Right? I mean, that's because it's pretty disruptive to do it anyway.
And in that case, it will be optional to enable post automatically, right? I mean, software can always pull the result and check.
Right.
Enable MACsec.
Okay, I think so we are good on this. I will update the documents and the header files. There might be some issue because enums will change, so there might be some ordering issue. I'll figure that out. Next week, I'm not available. I'm traveling for a conference. So, update on this will be a bit slow. Probably end of the week, I should be able to push all the updates. Is that okay? Shantanu, would that be okay? A little bit delay on my side.
Yeah, it's okay, but let's not delay anymore because we need to get this going.
Yeah, so what I will request the moment I pushed the agreed upon changes, then folks who are on the review list, please sign it off so that we can trigger a merge. But I'll try to do it next week, end of next week.
So I have a request for Shantanu and the others who are implementing this, is that so if somebody runs a diagnostics post, if it interferes with enabling or disabling MACsec, is there a jeopardy to passing the FIPS test essentially? In other words, I'm concerned that a subsequent running of post, let us say the post failed initially and the FIPS is disabled, and what will be the behavior if later on a diagnostics passes post? And vice versa. And vice versa.
If the hardware cannot support it, the layer above it, the SDK layer, should not permit running diagnostics until normal traffic is disabled. I mean, there should be some.
No, I'm not asking an implementation question. I'm asking about FIPS requirement question. Basically, if somewhere you are going to do a boundary in which you're doing a test, right? And this diagnostics hook for running post, where does it fit in the context of that boundary?
So from an application point of view, yeah, for an application, the FIPS situation is you run it when you start. And if it fails, the MACsec functions are expected to stay disabled. The diagnostic case doesn't impact FIPS. I mean, if an implementation chooses to subsequently run FIPS again, I mean, the lab or the certifications, they don't do that. I mean, the only scenario would be that, I mean, if somebody decides that their implementation only supports FIPS on create and post on create and never supports it
So
after,
their
that would
test
still be,
harness would not use that path, so it does not matter. The behavior doesn't matter. That's what it's
right.
okay. Okay. I'm always a little wary about complexity. It kind of it gives surprising. So that was a concern. So.
Okay, all right. So okay, guys, just heads up. By end of next week, the changes will be pushed out. I will send request to a review so that you will get an email. Please make sure you review on time. All right, that should be all. Tejaswini, I'll give it back to you. Thank you so much. I have to drop off for my 8:30 call, so I'll be dropping off.
Okay, sure. Yeah. Thanks, Jay.
All right. Thank you, guys. Bye.
Okay, I think we can move on to our next topic, Kishore. Next topic's on the next top group attribute for WCMP.
Yeah. Can you hear me?
Yeah.
All right. Let me share. All right. Can you see my screen?
Yeah.
All right. So I would like to discuss this PR where we would like to provide the application the ability to specify how a next hop group is achieving the weighting in the next hop group. Does it do it by repeating the members in proportion to their weight, with each entry having a weight of 1, versus anything that the switch intrinsically supports with respect to weighted cost multipath? So this is at a next hop group granularity, and that's in a nutshell what we are looking to add to the spec. Are there any questions on this?
Kishore, this is Ravi from Marvel.
Hey.
The intent is not clear. Hi, Kishore. Intent, Kishore, I'm trying to understand what is the expectation from the SI layer, right? This information anyway comes to us when I see the same next hop ID being passed multiple times. We know that the application is trying to achieve weighted ECMP by repeating the next hops. Instead, the application gives the next hop group members weight. We know it's trying to use weighted ECMP. If you give this attribute, what is the SI implementation supposed to do?
So thanks for the question. So one thing we noticed was that repeating the same next hop ID and saying weight equals 1 is kind of a hint, but it is not explicit enough, in the sense that its implementation, it's up to the implementation that it could still do its native way of doing weights and just say weight equals 1, versus what we are explicitly asking is repeat the next hop ID using the repeated way of achieving weights. The other thing that we ran into when we were trying to do this, just repeat the NH in the object list, was that inside Redis there is something that is almost like a sanity check, where an object cannot be repeated in an object list. So that again kind of makes it a bit, like unwieldy. And finally, like take the case where, you have high weights. Let's say you have two next hops, A and B, and we give like weights of like 127 and 1, right? Now this object list is really kind of uh, hard to read and hard to kind of reason about, because you just have uh, that same NH ID being repeated, like 127 times or in proportion to whatever its weight is. So it also makes that ASIC DB entry really hard to kind of reason about. So what this is doing is basically giving a hint or a metadata about the next hop group uh, to the implementation, saying that, we would like to repeat, uh, the members, and here are the weights, or just use the native weighting that the silicon provides.
Okay, sure.
Kishore, it doesn't solve any of the issues with the psi Redis and so on, right? You still have to repeat the
No.
entries and the async to be.
No, it solves it in the sense that, like the example I gave you before, right? Let's say there are two next hops, A and B, and I say A's weight is 127, B's weight is 2, and then I set this attribute to, let's say, false, right? So that will lead, the intent is that will lead the implementation to do the repetition internally. Whereas the ASIC DB entry will only have A, listed once with a weight equals 127, and B listed once with a weight equals 2.
Kishore, my question is, I understand what you're trying. The question is there a reason for you to say, let's say underlying ASIC supports native WCMP? Is there a reason for you to ask the ASIC to replicate instead of using the native WCMP?
Yeah, there is a use case we have, which kind of, relies on the application being able to specify this behavior.
Because right, this gets into implementation detail, right? All what you need is weighted SMP, and for each next top group, you give a weight. And how the underlying device or whatever implements, right? That is vendor specific. A device that doesn't support native WCMP can do the replication internally. The device that achieves weighted SMP with ASIC support, right? Okay, let's look at.
Yeah, so here is like some context on the use case, right? So this is kind of well known that in modern networks, source and destinations have multiple paths nowadays, and the path is chosen by computing a hash on the packet header and using that hash value with a modulo operation to pick the individual paths chosen. Also, like the hash function that is chosen on the packet path, if it is not well chosen, in the sense that the same hash function is used multiple times, it can lead to suboptimal load balancing, which can lead to some links being underutilized, some being overutilized, leading to congestion and longer latency, and all these eventually, impact the application's performance, right? So this is like a example topology wherein we are sending traffic from A to F. So A has two paths to B and C. Similarly, B has two paths to D and E, and C has two paths again. So if we use a hash function at A, roughly speaking, like if we say that hash values generated are in the range 0 to the max 16-bit or 32-bit, whatever the hash function generates. So we can see that roughly half the traffic should go, towards B, and another half goes towards C. Basically, hash values 0 to 4 go to B, and 1, 3, 5 go to C, so on. Now, if we use the same hash function at B, we see that one of the links from B going out will be underutilized or maybe not utilized at all. So we were and the reason to reuse hash functions is that the hash functions provided by the silicon, they are limited, and the paths that we have in the CLO topologies we use, they kind of are more they have more hops than the hash functions available. So we were looking to see how can this be alleviated. And one observation here was that the path that is selected has this two-step, in it, right? Essentially, you calculate the hash value on the packet header, and then you do a modulo operation to select one of those next hops. So in the example shown before, all the groups had like two next hops in the group. So if on the other hand, the application has the ability to control, the group composition. So for example, at B, if instead of having two next hops D and E with equal weight, we could modify their weights to be 3 and 2. Now the modulo is done with 5, and what we see is like 0 to 4, they still go to D, but 6, 8, they start taking the path which was not utilized. And you can see that with next hop group size of 5, we are now able to utilize a previously unutilized link. So this adjustment of next hop group size such that the size is relatively prime with the size at the previous stage, it can allow us to reuse a hash function in the packet path. They may not be on adjacent switches, but somewhere in the path you can employ this approach and kind of reuse a hash function. And the weight is not exactly what the weight we wanted before, which is 1:1. But we could get closer to 1:1 by using a prime group size, which is which is higher. For example, like 127 can give you a 64:63 balance, which is very close to 1:1, while also giving you better link utilization. So this, like doing this modulo with a prime basically means that the application has to be able to specify that a group needs to be repeated versus doing what the silicon inherently would support weights by. So that is like the use case that we had in mind when we wanted to introduce this knob.
A couple of things,
Kishore, yeah.
Kishore, right? One is that, I mean, for a couple of, I don't know if you remember it or not, a couple of years ago, Google introduced another attribute to rotate the hash function for this specific reason, because this polarization issues has been there for very long time in the networking switches, right? So are you saying that the rotation doesn't help at all? Remember
So,
that there's a rotate attribute which we can use to rotate the key of the hash function before it's calculated, and that rotation was supposed to solve this problem to a certain extent. That's my first question, and then I have another one.
Yeah, so the rotation, helps. For example, let's say you have a 16-bit hash function, right? Or a function which provides a 16-bit output. So the rotation will help if, let's say, you rotate by, let's say, 8 bits, and your group size is limited to looking at those 8 bits. If your group size looks at more than 8 bits, then again you have rotated, but you're still looking at some of the bits which you rotated around and basically shifted back in. So rotation is useful, and we use it to, for example, like take a CRC 16 and use it with offset 0 and offset 8 to say basically, hey, these are different bits in the CRC 16. Like one is the lower 8 bits and one is the upper 8 bits. But once your group size goes past 128, goes past 256, you are now again at different stages. You are using some of the same bits. So it becomes.
But that's because the hash calculation is 8-bit, which is sort of the issue, not the rotation, right? Typically, the hash calculation by the switch.
The hash calculation is 16 bits.
Or it could be even bigger. I mean, a lot of implementation have even wider, yes.
Right. It's just that the family of hash functions that are currently defined, there is CRC 32 high, low, and a bunch of CRC 16. So all of them are kind of going with a 16-bit output. So your point is valid that the offset helps, but it helps to a certain extent.
Okay, I mean, I understand that, because if you have 16-bit hash, in theory, you can rotate it 1 bit at a time and get 16 different outputs. And so even maybe that may or may not be enough, but I mean, I hope you experimented enough with it. But my second question is, if you look at the next hop attribute, right, for a slightly different reason, there's another way of doing it, in which, and that we use for something like consistent hashing or resilient hashing, where basically it gives you full control. The software or application has full control, where you not only specify the list of next hops, you can also specify the order in which they are actually done. So there's an index attribute. So what you can do is, let's say you want to create this next hop list with 127 members, for example. So you can create a list and you can say that index 0 is next hop 1 and so on. And then once in there, you can sprinkle in, index 59 is next hop 1 and like that. So you can basically create the list the way you want it And that gives you absolute control over how the hardware will do the hashing then. Because even with this case, even though you have that, it's not guaranteed that the application will actually take the list and do it in that order. They may actually, like for example, you did the example with 0, 2, 4, 6, and 8, right? But if the SI is doing some kind of implementation, they may actually take the list of next hops and sort it or do whatever with it, right? Or do it based on the order in which it's created. But if you use the index approach, for which there's already a existing attribute, you can have complete control.
I mean, I see what you're saying with respect to the fine-grained. I think that's
Yeah,
what
that
you're
gives you
referring to.
absolute control, right? Yeah.
Yeah. So even in this, if the order was not exactly D, right? The modulo 5 is what is causing like a 2:3 or a 3:2 split between the next hop. So we are actually not so interested in the order of the next hops, but the size of the group. So and
What I'm saying is
also,
that the order gives you another way to rotate. If you think about this way, right? If you use the order, in some way it gives you another way to rotate, because on different switches you can actually use different order, and that gives you kind of a different. I mean, I haven't thought about it; just came to my mind, but it gives you different rotation function on each hop, because now you can do both. You can not only control the weight, you can also control the sort of distribution or the order, because different hash, even though the hash is same on each switch, because the order is different, each switch will pick a different set of path for the same flow.
yeah, I mean, so basically, if switch, I don't know if you can see my arrow here.
Yeah, I can. Yeah, I
Okay.
can. Yeah.
So if switch be programmed like, not D and E, but E and D,
Yeah.
right? So these will then polarize to this link. So the order, like,
No, 0 to A will there's 0 to 4, but if those end up at B, because your issue is that only the even hash was calculated or something like that, right? Even for even hash, yeah, I mean, I'll have to think about it, but all I'm trying to say is that existing attribute gives you way more control than the new one which you're trying to introduce. And in the long term, it may be more beneficial, because now we have even more control, because these kind of issues keep popping up, right? I mean, it's
yeah,
not.
the thing with the fine-grained is that we are not necessarily interested in like, specifying the exact the order. We would rather let the SI implementation manage the SI implementation to take care of the memory management of the next hop group member table.
Okay.
So we just want this particular like hint or a configuration where we would like it to go back to repeat the members each with weight 1 and essentially allow us to use the group size as a way to enhance the load balancing.
Yeah.
Kishore, one thing I'm trying to understand is, right, while I understand your way how to avoid polarization, right? Anything in each tier, right? For example, all leaves will have same hash sheet, same rotate value and stuff, right? With that, you're saying you'll not get enough optimization, enough hash distribution. And for that, you want to replicate. But I didn't understand 3:2 versus 1:1. If you can go to that slide where you were talking about earlier. So no, this one. So are you saying I'm just trying to understand what you're talking about. Is it very vendor specific? What you're saying is if I have two next stops with weight, one of the next stop has a weight of 3, the second next stop has a weight of 2. Still the modulo is done as mod 2 and not mod 5. Is it what you're trying? I didn't understand How repeating solves this issue? I'm trying to understand that part.
Yeah, so the how the weighted how the ASIC intrinsically achieves weighting is like something we can't go into in this
Yeah.
forum,
Okay.
right?
Yeah.
But what we are saying is like just looking at what the modulo was before, which was modulo 2 versus modulo 5, is leading to a second link being utilized without assuming anything on the vendor implementation. Just repeating the next hops with weight equals 1, it gives you this kind of result on regardless of the underlying silicon.
Okay, I'm still trying to understand this. If 5, the hash 0, 1, 2, 3.
So
I'm
0
at
to
lost to understand. Yeah, the loss. All possible hash values should be here, right? I'm trying to understand
yeah.
how
So
one. I'm not okay.
All hash values don't end up here because this is switch B, which only got the even hash values.
Okay.
Now you got 0 to 4. So 0 mod 5, 2 mod 5, 4 mod 5, they all still take the original link D, right?
Okay.
But 6 mod 5 comes to E. 8 mod 5 again comes to E. So you see this repeating pattern of three values go to D, 2 go to E. The next 3 values again go to D, and then it's like a 3:2 split is what we
Yeah.
achieved.
Correct. And yes, this can be achieved by just having 2 next stops. Next stop 1 with weight of 3, and the next stop E with weight of 2, right? D with 3.
Yeah.
Why do you need it to be repeated, right? True weighted ECMP solution with the one next stop having weight of 3 and the other next stop with weight of 2 should achieve what we're given here.
If they use the same hash function, we are not sure that is achieved, and this is what we see in our deployment. So that's why we want this kind of a knob.
And that's one I agree with Ravi that I don't understand if you go with the native hardware implementation, you create 2 next hops, but give a weight of 3 to 1 and the 2 to other, it should do a load balancing in the ratio of 3:2. So sort of fail to understand how software creating or this is SI implementation creating 5 next hops. In this case, this is what you want, right? For SI to create 5 next hops with 3 of one type and 2 of one will help because
Well,
it is same as the hardware doing it.
We want SI to program entries in the next hop group member table with the weight of 1 and repeating the members in the proportion that in the
That's what I'm
proportion
saying.
of
How is it
weight.
different? If you do that, then the hardware should do a load balancing 60:40 ratio, right? If you do the native ECMP also, it will do 3:1. Sorry, 3:2. So I don't see the distinction unless there's something very, very hardware specific.
So the hardware specifics details, like I said earlier, I can't go into that. But the way the hash functions that are currently in the SI spec are specified, even for weighted, you specify the same hash functions. So you don't have like another set available. So you are still using CRC in both the hops, some version of CRC. And that repetition, even when you do weighted, it has this polarizing effect.
Yeah, but Kishore, the hash function is same for all the cases, whether hardware does ECMP, whether the SI does the repetition or where the application does the repetition, all of them have the same hash function. So that doesn't change with any approach. So the problem doesn't go away. So I'm just trying to understand how our platform, let's say, will
doing
behave
replication
differently.
is like I mentioned, right? We don't want the ID to be repeated in the OID list and in ASIC DB entry and so on. So we are just giving that as this control, right?
So that part I understood, but like Ravi is asking, right, with this being true or false, what I'm trying to understand is that, I mean, my understanding is that in either case, our hardware will do the same thing, in the sense that the behavior will be same in either whether the software creates 3 and 2, basically an extra group of 5 and repeats 3 next stops and 2 next stops, or we program the hardware to do a weight of 3:2, that the actual behavior seems to me will be same. So I'm failing to understand how this will help. Ravi,
I'm also, I think I agree the same. Looks like it's a particular ASIC has a bug or something, and we are trying to bring in hints for this particular ASIC bug, I'm thinking.
This definitely has to be some basic bug. Yeah. No, I know you don't want to go into it, but there has to be some explanation as to how our implementation is supposed to behave differently, right? Because it will do same thing. I mean, in the end, the same output will come out of the switch.
No, if you're saying it's going to do the same thing, then maybe that is true for some instantiation of this, right? This is probably only gonna really change anything if the silicon has the ability to support weights intrinsically using some algorithm versus how it was, in previous gen, where you were actually repeating the next hops in the member table. So if
I got that point, but if the hardware doesn't support natively, there's only one way, right? So that's fine. But I'm saying in the case hardware supports it natively, and then I fail to see the difference, because if the hardware does natively, it will basically try to do in the 60:40 ratio. And if you do through the SI, it will also try to do the 60:40 ratio, because that's the way SI programmed it, right? By creating 5 members. So the behavior will be same, is what I'm saying, if my hardware supports native WCMP. If hardware doesn't support native WCMP, there is no question, right? There's only one way, so there's nothing to discuss.
Yeah, I think
I'm missing something there.
Yeah, that difference is like is like an implementation kind of the detail.
No, not implementation, but if you look at logically, right? I understand that implementations are different, but here, right, because the psi attribute, right, there has to be some. I'm just trying to understand. I mean, how do I? The output has to be different, right? Logically, right? Because either way, you're saying the ratio should be 3:2, and you don't care about order and all that. So if you care about order, then it makes no difference, because with hardware implementation, you cannot control the order. But if you wanted to control the order like fine grain, then you can say, yes, I want that because hardware doesn't give me that. But here, both cases give you 60:40 ratio.
Yeah, it theoretically, if you had, like traffic before, like let's say A gets traffic, right? It gets 10,000 flows. The fact that you get hash traffic at B means that you don't see the same exact 10,000 flows. You're seeing something which already got hashed.
No, the polarization issue is well understood, but polarization issue is understood very well. But I'm saying that is independent of the weighing done by B, right? Because B as a switch doesn't know.
Let's assume that B with weights of 1:1, right? If it uses CRC, it will not be able to split this traffic half and half. If it did, then we are done. But that's not what happens.
That is nothing to do with the fact that Yeah, very good. Yeah.
No, I'm just, I think, Kishore, if I make the weights as 3 and 2 for each of this, right? Still the hardware has to do some kind of CRC on 5 slots. Let's say for link B and D, the BD link, I'd keep a weight of 3, and for the BE link, I give a weight of 2. The ASIC is internally now going to have 5 slots, right? And it's going to distribute whatever 0 to 4 flows that come to B, it's going to distribute among this 5. Whether you repeat it or whether it's a weighted ECMP, like Ashra says, right? The hardware is going to do some kind of this whatever limited hash functions we have, right? It's going to do the same hash function. I'm just the same question as Ashutosh. How would repeating make the hardware give a different performance than using the native weighted capability of the ASIC?
So repeating gives better performance when it's repeated. That part, I think, is clear from this example, right?
Not really, because the same thing could be done with weighted ECMP also would be doing the same thing, and native WCMP would do the same thing.
No,
Yeah,
like
the exact same thing will happen in both cases, whether you repeat it or not, right? In the end, the hardware implementation is going to take, it will have 2 next hop, and 60% of the times based on the hash, you'll pick the first next hop, and 40% of the time based on the hash, you'll pick the second next hop. That is same as repeating. I mean, yes, the ASIC DB, the only thing which will, even in this case, there will be nothing different other than this attribute. And yes, by using software, you're consuming more next hop group members.
yeah,
that is
so
the only thing I see being different. But that's
that
consuming
is
more resources for no benefit.
No, there is a trade-off. I agree that we are going to use more resources, but the benefit that we get by just going from like ECMP of 1:1 to an ECMP of 3:2 is one link which was not getting utilized at all.
Kishore, we are not debating that. That 1:1 to 3:2 is very well understood. We agree. You can do 3:2. That's perfectly fine. That is definitely better. But the question is that how does doing replication instead of hardware native ECMP makes a difference? Because in both cases, you are doing 3:2. So we're not comparing 1:1 to 3:2. That is very well agreed that going that way will get out of the polarization issues in many cases. That is understood and agreed. But if you do 3:2, having 2 different ways, what is the difference? That is what we fail to understand.
Yeah, I can't really say more than what I have said.
Okay. So, do we want to continue this over the next meeting, or continue it offline? Continue the discussion offline, Kishore?
Yeah, I can probably take any comments offline if there are no further questions on like the proposal itself.
I think the proposal itself looks like something specific for an ASIC bug, right? So that's what we're all saying. I think at least we should get more than 2 vendors to say, yeah, this is generic, because we don't want just a vendor who has this bug to say, yeah, this is good, right? We need at least 2 ASIC vendors to say, yeah, this. Because what we fail to understand is what should the SAI implementation do differently whether you're repeating or whether you're natively using WCMP, right? That is
No,
not coming out.
that part is like what is specified here, right? What it should do differently is if it supports an intrinsic way of weighting as well as a way of repeating the members, then that is what is what this knob specifies. If it only ever supports one way of doing it, then it's like not applicable. You can just return not supported or fail, right?
Kishore, no, that's not the point. The question is, what is the functionality you're achieving is not clear by doing this. A device supports native WSMP, but asking it to not do weighted ESMP without using the device capability, right?
So that is what the application's preference is. So I gave the example, but
because that example, the main slide, right, where it's showing the 3:1, 1:1 split, maybe it's specific to one particular ASIC. That's the problem here.
So
and
let
also,
me
Kishore,
follow
the
up
example
offline
you're
on that.
giving is basically telling you that the WCMP is good, which we agree that WCMP is good. But the example doesn't talk about this at all, right? This only tells you how the WCMP performs better than the regular ECMP, and that is not what we're debating, right? So that example has nothing to do with this, right? Whether you do in hardware or does, how does it help? That example doesn't talk about that.
Sorry, I didn't get that part, Ashutosh.
See, the example only talks about whether WCMP is better in that scenario or not, right? So that example is talking about benefits of WCMP over regular ECMP. So that is fine. It is not talking about how one approach versus other with this attribute is better. Because
So
what we keep saying is that in both cases, the output is same.
We cannot go into the internals of how WCMP is implemented to compare the two, right? So that I cannot do that. So
No, but WCMP is simply a weight, right? So 3:2, any implementation should achieve 60:40.
Well,
What I'm trying to say.
that depends on the incoming traffic as well. If the incoming traffic is like hash traffic, then WCMP is like using hashing to certain extent as well, right? So
Even with
if
the replication, it does use, most implementations I'm aware of, even with replication in the end, because the hardware doesn't know that replication happened. So for hardware point of view, you're creating a ECMP group of size 5, and then is going to use hashing to figure out how to load balance among those 5, right? So hashing is going to use anyway. Yeah.
So for that, then it can only support value of false for this, right? So it can
No, it's not support.
choose.
We can support both. What we fail to understand is the benefit of it and whether the device is expected to behave differently or not.
That is up to the device. So that's what I think we are kind of going back to the same point. So without going into the details in this forum, I don't think I can convince you. So we can take this offline if you like.
So Kishore, one quick question on your slide where you had the topology, right? The one with the polarized hashing, is that actually with weighted? Like here, are you saying that B to D is 3 and B to E is E, but done natively?
Again, that goes to the implementation, but in this case, all the weights are equal to 1 on all the devices.
Okay, so yeah, then we are not really comparing the same thing, right? You're comparing 1:1 in done natively versus 3:2 done in software. So maybe like you should be comparing 3:2 done in hardware versus 3:2 replicated.
Exactly, that's what I'm trying to say too. Yeah, suggesting. Yeah.
So this is based on work which was like done like, let's say, even 5 years back, and I can point you to the paper that was published by our research team. So at that time there was no like native capabilities even, right? It was all like repeated in the hardware, and this kind of approach was used to like allow us to reuse hash functions on the path. Now with native coming in, it's not that this is a panacea or it has solved all the problems. There is still polarization with native WCMP as well, because the same hash functions are used there as well. So we want the ability to, for paths where we see the hash function has to be reused, we want the ability to fall back to the repeated approach, because that is a tried and tested approach which leads to this kind of a scenario. So that is essentially what this this knob does. And like you said, earlier generation devices will not support both values of this knob, right? They may only support the false. There may be silicon which have totally cut over to the true way of doing things and cannot support the false. So both of those silicon will just not be applicable. They can just say not supported. It's only the silicon which can support both of these, where we see some value in falling back to the repeated way of achieving weights.
Okay. Um, I guess it's just like probably we can look at it as a way of not using what the hardware provides, right? So yeah, I guess I'll leave it up to Ravi and folks to weigh in on this. Yeah.
Maybe we should take it offline, and if needed, again have a meeting. Kishore, I think we'll have to take it offline, and if needed, have another follow-up meeting.
Okay, sounds good.
Okay.
Thanks for
Yeah.
explaining, Kishore. Yeah, thank you.
Yeah, thank you for your time. Thanks.
Thanks, everyone.
Thanks, Kishore.
Yep.
Thanks, Kishore. Thanks, everyone.